Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In the previous lecture, we did Stirling's formula for central interpolation, and in today's lecture, we'll move forward to another formula for central interpolation, which is known as Bessel's formula. Like Stirling formula, we just have to know what the formula is and when do we apply it. In Stirling formula, we used to apply it when x lies between minus half and plus half. Here, Bessel's formula is applied when the x lies exactly at the center, means between 0 and 1, which is 0.5, as we all know. We have to know the formula, first the formula, then how to apply it in a question, and why is it applied. All these three things should be known, and if we know all these three things, we can solve any questions on Bessel's formula. So let us begin. Bessel's formula for central difference, or you can say central interpolation. First, I'll write the formula, then we see when it is applied. So the formula states that if we have to find anything which is Fu, then we will do it like this: F naught plus F1 divided by 2. There is no trick, so you have to learn it by heart. Second term is U minus half delta F naught. Third term is U into U minus 1 upon 2 delta square F naught plus delta square F minus 1 upon 2. Then the fourth term is U minus 1 into U minus half upon 3 factorial into delta cube F minus 1, and so on, but we only have to learn it till fourth term. In examination, they won't ask you more than this, or they can ask you less than 4 but not more than 4. Till fourth is the safe one, so we are learning one extra for this. And similarly, we did in Stirling's formula, and if you have any confusion what was Stirling's formula, then you can re-watch the video of previous lecture video of ours, in which I have explained how what is Stirling formula, when it is applied, and how it is applied, everything of that. So this is Bessel's formula, and we are learning it up till fourth term only. Let me box it. This is our Bessel's formula. Now the second part is the thing that you should keep in mind for Bessel's formula is how, when is it applied? It is applied when the value of x lies between 0 and 1, or we can say lies at between 0 and 1. The central point will be 0.5. This should be kept in mind. Stirling formula, if we talk about Stirling formula, then the range was minus half to half. Here the range is 0 to 1. And since it is the central difference formula, so exactly at the center, 0.5 will lie. So this was about Bessel's formula and why is it applied. Now let us move towards a question. How do we attempt a question? Let me write. The question says that using y24 equals to y20 equals to 24, y24 equals to 32, y28 equals to 35, and y32 equals to 40. We have to find y25 using Bessel's formula. These formula also contain errors, so if you played smart in the examination and you do directly with any other formula, then your answer will be wrong, because Stirling's and Bessel's are also two different formulas having two different kinds of errors, and hence the same question provides different answers for the same question. Different answers is provided by both the methods, Bessel's and Stirling. So don't use it. Just revise this formula again and again and practice questions as many as you can, so that in the examination you will be able to solve the questions based on this Bessel's formula. So we have been provided with this. Now, as you all know that we divide the table, we'll make a table, and we'll divide it into some parts, where we'll write x, fx, delta of fx, delta square of fx, delta cube of fx, and delta raised to the power 4, which will not be needed in this kind of question, but still I am creating that space. So here we'll write x, the values of x. Here we'll write fx, or let us use only this. Then delta of fx, delta square of fx, delta cube of fx, and delta raised to the power 4 of fx. In front I'll write them. So 20, 24, 28, and 32. And the corresponding values of fx is 24, 32, 35, and 40. We'll take slowly and gradually so that you will be able to understand how to attempt in the examination. And you can practice on many other questions to get a good speed. So first is delta. So 32 minus 24 will be 8. 35 minus 32 will be 3. And 40 minus 35 will be 5. Now the second difference. 5 minus 3, okay, first 3 minus 8 will be minus 5, and 5 minus 3 will be 2. And if I differentiate this, 2 minus minus of 5, 2 minus minus of 5 will be 2 plus 5, which is nothing but 7. So it is 7. And since we've got one term here, we will not get any term in this column, and this column is useless for us. Now, since we have to find y25, so the nearest value of 25 is 24, so we'll keep it at 0 at the starting point. This, let us keep it as minus 1, 1, and 2. So we have created this table. Okay. Now we'll solve it here only so as to get the answer. Now, The Bessel's formula, let us write what was our Bessel's formula. Bessel's formula states that f of u, here u is 25. So 25, f of 25 should be equal to f naught plus f1 upon 2 plus u minus half into f delta f naught plus u minus 1 into u upon 2 bracket delta square f naught plus delta square f minus 1 upon 2 plus the fourth term square. Till square we have done, we have to calculate till cube. So here it will be u minus 1 u minus half upon 3 factorial into delta cube f minus 1. These values we have to calculate. Now before calculating all of this, first we have to calculate a plus hu should be equal to our value which has to be found, which is 25. Now a is the starting point. I've told you the starting point is 24. So instead of a, we can write 24. H is the width. You can see the width of x. The all the widths are equal, which is 4. 20 plus 4 is 24. 24 plus 4 is 28. 28 plus 4 is 32. So instead of h also, we can write 24 plus h is 4 into u is equals to 25. So u is nothing but 1 upon 4, which is nothing but 0.25. So we've got the value of u and f naught. Now this is the value of f naught. The one which is corresponding to 0 is the value of f naught. The one which is corresponding to minus 1 is value of f minus 1, and the one which is corresponding to 1 is the value of f1. And this is delta of f minus 1. This is delta square of f minus 1, and it is delta cube of f minus 1. Then this is delta of f0, delta square of f0, and this is delta of f1. This I have told you earlier in Stirling's method as well. Here also I'm telling you. I'm just putting the values here. So f of 25 will be equal to f naught plus f1. F naught is 32 plus f1 is 35 upon 2. This is our first bracket. Then the second is u minus half. U is 0.25, half is 0.5 in bracket into delta f naught. Delta f naught I have told you right now, which is equals to 3 plus u minus 1 into u. U is 0.25, u minus 1 is 0.25 minus 1, which will be equal to minus 7.25 upon which will be equal to 0.75 upon 2 into the next bracket, which is f of z delta square of f of 0, which is 2 plus delta square of f of minus 1, which is minus 5 upon 2. Then the fourth one is u minus 1, which is 0.25 minus 1, u minus half, which is 0.25 minus 0.50 upon 3 factorial, which is 6, and delta cube of f minus 1, delta cube of f minus 1 is 7. So we'll multiply it by 7. And solving, when you'll solve this, you'll get your final answer as f of 25 equals to 32.94 something, and so on. You can take up till the second digit after the LCM, after the decimal. So this is how we solve Bessel's formula. As and when it will come in examination, with practice you'll improve yourself and solve it within the time limit. This was harder. This was an easier calculation one, and these kind of questions only come in the examination. They won't ask you difficult calculation question, because that will require a large amount of time, and in objective papers we are not allowed to take calculators as well. So that is one point of these. And the formula should be learnt by heart, then only we can solve and attempt these kind of question. If we don't know the formula, then we should I would suggest you to skip these kind of questions, because it is just a time waste to attempt on these. Let us see one PYQ on Bessel's formula. This PYQ states that Bessel's interpolation formula is most appropriate when P is equals to x minus x naught upon h, which means x lies between. P here examines u. So I have told you, since it is central difference formula, so we all know that central difference formula, x or u, the difference, because we can write f of x or we can use f of u, both are equal. F of x lies between 0 and 1 exactly. So central means exactly in between, and exactly in between it will be 0.5. And 0.5 lies in which range? Minus and plus 0.25? No, it does not. No, it does not lie in this range. 0.25 and 0.75, yes, it lies between 0.25 and 0.75. Let us see rest answers as well. Lies between 0.75 and 1? No. Is greater than 1? No. As we can see in on a number line, if I place this is 0, this is 1, and this is minus 1. In between them will be 0.25, 0.5 and 0.75. These are all in negative. Here also it will be 0.25, 0.5 and 0.75. Now 0.5 lies somewhere here. So the first range is minus 0.25 to plus 0.25. Minus to plus. This to this. It does not lie here. So we'll cancel this out. First one. Second is 0.25 and 0.75. From here to here. Yes, it lies between them. So this is correct. Rest also I can show you. Lies between 0.75 and 1. 0.75 is this, 1 is this. It does not lie between them, so it is also wrong. And the fourth one is greater than 1. Greater than 1 lies here, so it does not lie here as well. That's why the fourth option is also wrong. So this is how they ask questions in the examination. So you need to not only know what is the formula and how is it applied, you also should know when is it applied. So this was all for today's lecture. I hope that you got whatever I have taught you in class. And if you are still facing any doubts in solving question, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.